Hello everyone, today we're gonna solve the maximum erasure value problems. This problem asks us to choose a subarray containing unique element, and the score of is a subarray is the sum of all of the elements in the subarray, and we need to return the maximum score we can choose from choosing exactly one subarray. And for example, if we have 4, 5, 6, we're gonna choose this segment so that the sum of them gonna be 17. And this one is like an upgraded version of the longest substring with the repeating character problem. Version of this without character. If you haven't seen my video on this problem before, I highly recommend you to watch this video first and try to solve this problem first before we try to solve this problem. This is because the idea of both of them are exactly the same. So what we're gonna do is that we're gonna use true pointer and hash map. So we're gonna use two pointer to choose a subarray without any duplicate elements. So for example, first of all, we're gonna have right like this, left from this, and then we're gonna extend the right to the right side. So we're gonna have right to this and right to this, and then if we have an element with a duplicate value, we're gonna move the right position to this, and then we continue to move the right side to this and right side to this, and finally we're gonna have this segment. This subarray is having the highest score, and we also have a comments for this problem by seeing the nums values. We can see that the nums value, all of them are numized, right? Is greater or equal than 1, which means that they all positive. So we can just consider the longest subarray instead of consider all of the, the smaller subarray in this segment. For example, if we have 2 to 5 is the longest one, we can just need to consider the longest one instead of consider all of the smaller one within this side. For example, we can ignore the 3 to 5, 4 to 5 segment, because obviously the segment will not have the sum greater than the longest one. So we have another comments, another uh, theorem for this problem as well. And for the second one, we're gonna have this 5 to 5. So first of all, we're gonna start from this, and then we extend to this and this, and we have this segment, right? And then when we meet this value, we're gonna have duplicate value. So we're gonna need to remove this and remove this, right? So we're gonna have the new left with this, and we're gonna consider this segment. This segment are gonna have the value of 8. This one has the value of 3. And then we continue to extend right to this. Then we're gonna have segment from this to this, and we're gonna have the sum of them equal to 8. And then we're gonna do the same here. We're gonna extend right to this, and we're gonna need to remove this. We're gonna have the new segment left here and right here. So we're gonna have this segment, then we extend this. We're gonna have this segment. This one is 7, this 8, and then we extend to this. We're gonna need to remove this this so that we're gonna have this segment left right here and right here, and this one have the sum of 3, and we extend to the final one. We're gonna have 8, and the maximum number of all of them is 8, 8, 8, 8. So the largest score, the highest score we can get is 8 in this case. So let's jump into the coding part. So first of all, we're gonna need to use the key value structure to store the frequency of each number. So let's say I'm gonna use the key and value represent our number and frequency of the number of that number. And then we're gonna use two pointer left right to maintain all of the unique super array. And then we need to know that in this case we only have the uh, positive number, and if we have negative number we cannot do that way. So that's why you need to ask your interviewer if you meet it question that do we have like negative number. So if we have negative number we have to think about that different way. So first of all we're gonna have a order map, order map in integer the frequency of a number, and then we're gonna have the left pointer, we're gonna have the right pointer from 0 to then we're gonna increase the frequency of that number by 1. And if we have the frequency of that number is greater than 1, we're gonna need to shrinking our subsequent by increase left by 1 frequency of the number left to update it. Let's say it first. And I think we need to calculate the sum of them first. So let's say we have the current sum 0 and our max sum 0 as well. So we're gonna have this one, the current sum, we're gonna increase this minus left, then we update the result with current sum. Finally we're gonna return result right here, and the time complexity for this one is O, and the space complexity. And the topic for this problem is basically 2 pointers, and I think that's all for this one. So Perfect. Let's see how it goes. We have frequency is, oh, they get the sum of all of them. Let me double check it again. Oh, I think I need to subtract this one to shrinking my window down instead of plus one. So yeah, that's makes sense. Perfect. I think that's all for this question. Submitted to goes perfect. And again, if you haven't seen my video on longest substring without repeating characters, I highly recommend you to try this problem and watch the video before you try to solve this problem. Okay, that's all for this problem, and I hope you guys can solve it correctly. Thank you.